Welcome. In this video, I'm going to give an overview and demo of the Amazon GuardDuty EKS protection feature. To get started, if you're not familiar, Amazon GuardDuty is a security monitoring service that analyzes and processes foundational data sources such as AWS CloudTrail management events, AWS CloudTrail event logs, VPC flow logs, and DNS logs. It also processes features such as Kubernetes audit logs, RDS login activity, S3 logs, EBS volumes, runtime monitoring, and Lambda network activity logs. It uses threat intelligence feeds such as malicious IP addresses and domains and machine learning to identify unexpected, potentially unauthorized, and malicious activity within your AWS environment. GuardDuty then provides you with actionable findings so that you can remediate this activity in your environment. EKS audit log monitoring helps you detect potentially suspicious activity in your EKS clusters with Amazon Elastic Kubernetes service. When you enable EKS audit log monitoring, GuardDuty immediately begins to monitor Kubernetes audit logs from your Amazon EKS clusters and analyze them for potentially malicious and suspicious activity. It consumes Kubernetes audit logs events directly from the Amazon EKS control plane logging feature through an independent and duplicative stream of flow logs. This process does not require any additional setup or affect any existing Amazon EKS control plane logging configurations that you might have. So with that said, let's jump into the console and look at a couple findings and see the details that Amazon GuardDuty gives you based on these EKS audit log findings. Now jumping into the AWS console, we're in the GuardDuty console findings page where we can see that I've filtered by a couple different findings that we'll use to walk through a couple of these EKS protection finding types. First, let's click on the Policy Kubernetes Anonymous Access Granted finding. This finding lets us know that the system anonymous user was granted API permissions on an EKS cluster. This enables unauthenticated access to permitted APIs. If this behavior is not expected, it's possible that this is a misconfiguration or that credentials could potentially be compromised associated with this EKS cluster. So as we walk through the finding details of this finding type, first we can see a link to investigate with detective. We can also give feedback to the Amazon GuardDuty team and suggest whether this finding was useful or not useful. We can see overview information of this finding type. We can see the severity is high, the region is US East 1, how many times we've seen this finding associated with this given resource, the account ID, the resource ID, when this was originally created, and when it was last updated. If we continue to scroll down, we can see information about the resource that was affected. We can see the cluster details associated with this resource. We can see the Kubernetes details such as the username and UID and session name, tags associated with this resource, and then the action that created this finding in the first place. So we can see that there was a Kubernetes API call that was made, the request URI being a cluster role binding. We can see the verb was to create, the status code being 201. We can see associated parameters, once again, when this was first and last seen. And then if we look down even further, we can see actor information. What was the IP address associated with this action and the location of that IP address. With this information, you'll have the details that you need to respond to this potentially malicious activity in your AWS environment, whether that's following up with the resource owner or providing some remediation, whether that be via automation or through manual actions. So now that we've looked through the first finding, be it a policy-based finding through anonymous access being granted in this environment, let's go to our next finding type that we're going to look at, which is associated with privilege escalation, Kubernetes privilege container. So quickly, a privileged container with root level access was launched on an EKS cluster associated with this resource name. If this behavior is not expected, it may indicate that your credentials are compromised. Giving a container root level access is not a best practice, and so something that could be potentially malicious in this environment. So if we look at the details associated with this finding type, once again, we see the link to investigate with detective. We can provide feedback whether this was useful or not. We once again have overview information. We can see that it's the same resource ID, same account ID. We have a count of 1 this time. Severity is medium. When this was originally created, when it was last updated. If we can scroll down, we see lots of the same information associated with the resource being affected. What was the EKS cluster details, the workload details associated with this. So for example, the name of the workload, the type, which this type is a deployment, the namespace being the default namespace. We can see container level information, the name, image associated with this, the user details associated with this finding type. And then if we continue to scroll down, we can see the action being an API call. Once again, the verb being create, the request URI being the deployments URI. And then we can see actor information. These two findings together give us information on how access could have been granted in the environment and some follow-on activity that could potentially be associated with privilege escalation in this environment. Once again, GuardDuty gives us lots of finding details and information to understand the activity that's happening in the environment, the resources that are associated with this activity, giving you the information that you need to address what's going on in this environment, whether that's via manual actions, following up with teams that are running these workloads. And something else to keep in mind is all GuardDuty findings are sent to Security Hub and EventBridge so that you can create automation to collect either this information as solutions such as Security Lake, be able to track it via a ticketing system, or use a service such as Lambda or Systems Manager to run automation based on these findings happening in an environment. In this video, we went over a demo of the Amazon GuardDuty EKS protection feature and walked through 2 different findings and the details Amazon GuardDuty provides. If you're interested in learning more, please visit aws.amazon.com/GuardDuty.